The analysis of variance or the ANOVA. It is a collection of statistical models used to assess the differences between the means of two independent groups by separating the variability into systematic and random factors. It helps to determine the effect of the independent variable on the dependent variable. The formula is computed by summing the squared differences between each treatment or group mean and the overall mean. The squared differences are weighted by the sample sizes per group or NJ. The error sums of square is the formula below. The ANOVA table above is organized as follows. The first column is entitled The Source of Variation and delineates the between treatment and error or residual variation. The total variation is the sum of the between treatment and error variation. The second column is entitled The Sums of Squares or SS. The between treatment sums of the square is the formula below. Column contains the degrees of freedom. The between treatment degrees of freedom is df1 is equals to k minus 1. The error degrees of freedom is df2 is equals to n minus k. The total degrees of freedom is n minus 1. It is also true that k minus 1 plus n minus k is equals to n minus 1. The fourth column contains the mean of squares, or MS, which are computed by dividing sums of squares, or SS, by degrees of freedom, or DF, row by row. Specifically, MSB is equal to SSB over K minus 1, and MSE is equal to SSW over N minus K, dividing SST over n minus 1, the process of variance or the total sample. The F statistic is in the rightmost column of the ANOVA table and is computed by taking the ratio of MSB over MSW. And it is computed by summing the square differences between each observation and the overall sample mean. In an ANOVA, data are organized by comparison or treatment groups. If all of the data were pulled into the single sample, SST would reflect the numerator of the sample variance that is computed on the pool or total sample. SST does not figure into the F statistic directly. However, SST is equal to SSB plus SSW. Thus, if two sums of the squares are known, the third can be computed from the other two. Here is the ANOVA table where X is individual observation, X with upper line is the sample mean of the jth treatment or group, X with two lines on the upper is the grand mean, K the number of treatments or independent comparison groups, and n is equal to the total number of observations or total sample size. df1 degrees of freedom between, df2 degrees of freedom within, and df3 degrees of freedom total. It is computed by summing the square differences between each observation and its group mean, or the square differences between each observation in group 1 and the group 1 mean, the square differences between each observation in group 2 and the group 2 mean, and so on. The double summation, or SS, indicates the summation of the square differences within each treatment and then summation of these totals across treatments to produce a single value. Or This will be illustrated in the following examples. The total sums of square is this formula.
Two types of ANOVA. One-way ANOVA. The one-way analysis of variance is also known as single-factor ANOVA or simple ANOVA. As the name suggests, the one-way ANOVA is suitable for experiments with only one independent variable or factor, with two or more levels. A one-way ANOVA assumes, first, the independence. It is the value of the dependent variable for one observation is dependent of the value of any other observation. Second, normalcy. The value of the dependent variables is normally distributed. Next is variance. The variance is comparable in different experiments groups. Last, the continuous. The dependent variable is continuous and can be measured on a scale which can be subdivided. Full factorial ANOVA, also called two-way ANOVA. Full factorial ANOVA is used when there are two or more independent variables. Each of these factors can have multiple levels. Full factorial ANOVA can only be used in the case of full factorial experiment, where there is use of every possible permutation of factors and their levels. This two-way ANOVA not only measures the independent versus the independent variable, but if the two factors affect each other, a two-way ANOVA assumes, first, continuous. The same as one-way ANOVA, the dependent variable should be continuous. Second, independence. Each sample is independent of other samples, with no crossover. Next, variance. The variance in data across the different groups is the same. Normalcy. The sample are representative of normal population. Categories. The independent variable should be in separate categories or groups. Another type of ANOVA, N-way ANOVA or MANOVA. It applies to multiple independent variables that affect the dependent variable. It is more effective than analysis of variance, as one can use it to observe multiple dependent variables simultaneously. Multivariate analysis of variance or MANOVA is an extension of the univariate analysis of variance or ANOVA. In an ANOVA, we examine for statistical differences on one continuous dependent variable by an independent grouping variable. The MANOVA extends this analysis by taking into account multiple continuous dependent variables and bundles them together into a weighted linear combination or composite variable. The MANOVA will compare whether or not the newly created combination differs by the different groups or levels of the independent variable. In this way, the MANOVA essentially tests whether or not the independent grouping variable simultaneously explains a statistically significant amount of variance in the dependent variable.
One-way ANOVA example. Suppose we want to know whether or not 3 different exam prep programs leads to different mean scores on a certain exam. To test this, we recruit 30 students to participate in a study and split them into 3 groups. The students in each group are randomly assigned to use one of the 3 exam prep programs for the next 3 weeks to prepare for an exam. At the end of the 3 weeks, all of the students take the same exam. The exam scores for each group are shown below. Group 1, 85, 86, 88, 75, 78, 94, 98, 79, 71, 80. Group 2, 91, 92, 93, 85, 87, 84, 82, 88, 95, 96, and Group 3, 79, 78, 88, 94, 92, 85, 83, 85, 82, and 81, with a total of 30. Step 1. Calculate the group means and the grand mean. First, we will calculate the mean for all the three groups along with the grand means. Group 1, 85 plus 86 plus 88 plus 75 plus 78 plus 94 plus 98 plus 79 plus 71 plus 80 divided by 10 equals 834 divided by 10 is equals to 83.4. Group 2, 91 plus 92 plus 93 plus 85 plus 87 plus 84 plus 82 plus 88 plus 95 plus 96 over 10 is equals to 893 divided by 10 is equals to 83.3. Group 3, 79 plus 78 plus 88 plus 94 plus 92 plus 85 plus 83 plus 85 plus 82 plus 81 over 10 is equals to 847 divided by 10 is equals to 84.7. We will add all the three means to get the grand mean, which is 83.4 plus 89.3 plus 84.7 divided by 3 is equals to 257.4 divided by 3 is equals to 85.8, which is the grand mean. Step 2. We will calculate the sum of squares between or SSB using the following formula. SSB equals summation of n, which is the sample size of group, open parentheses, the mean of the group minus the grand mean, close parentheses, squared. We will substitute the following. Summation of n is equals to 10, open parentheses, the group mean of group 1 is 83.4 minus the grand mean, which is 85.8 squared, plus the group 2. Summation of n is 10, open parentheses of group 2 mean is 89.3 minus the grand mean, which is 85.8, close parentheses, squared, plus the group 3. Summation of n, 10, open parentheses, 84.7 minus 85.8, which is the grand mean, close parentheses, and squared. Next, we will subtract each group which is inside the parentheses. 83.4 minus 85.8 is equals to negative 2.4. 89.3 minus 85.8 is 3.5, and 84.7 minus 85.8 is negative 1.1. 10, open parentheses, negative 2.4, close parentheses, squared, plus 10, open parentheses, 3.5, close parentheses, squared, and the last one is 10, open parentheses, negative 1.1, close parentheses, squared. Now we will square the following, which is inside the parentheses. Negative 2.4 squared is equals to 5.78. 3.5 squared is equals to 12.25. And negative 1.1 squared is equals to 1.21. Which is equals 10. Open parentheses 5.76 close parentheses plus 10 open parentheses 12.25 close parentheses plus 10 open parentheses 1.21. Now we will multiply the following. 10 multiplied by 5.76 is 57.6, and 10 divided by 12.25 is 122.5 plus 10 multiplied by 1.21 is 12.1, and now we will add the following. 57.6 plus 122.5 plus 12.1 is equals to 192.2, which is our SSB. Step 3. We will now calculate the sum of squares within or SSW using the following formula. SSW equals summation, open parentheses, the observation in group minus the mean of the group, close parentheses, squared. Group 1. 85 minus 83.4 squared plus 86 minus 83.4 squared plus 75 minus 83.4 squared plus 78 minus 83.4 squared plus 94 minus 83.4 squared plus 98 minus 83.4 squared plus 79 minus 83.4 squared plus 71 minus 83.4 squared plus 80 minus 83.4 squared. Now we will subtract the following. Inside the parentheses, 1.6 squared plus 2.6 squared plus 4.6 squared plus negative 8.4 squared plus negative 5.4 squared plus 10.6 squared plus 14.6 squared plus negative 4.4 squared plus negative 12.4 squared plus negative 3.4 squared. Next, we will find the square of the following, which is 2.56 plus 6.76 plus 21.16 plus 70.56 plus 59.16 plus 112.36 plus 213.16 plus 19.36 plus 153.76 plus 11.56 and add the following, which is equals to 640.4. We will move on to group 2, equals to 91.89.3 squared plus 92.89.3 squared plus 93.89.3 squared plus 85 minus 89.3 squared plus 87 minus 89.3 squared plus 84 minus 89.3 squared plus 82 minus 89.3 squared plus 88 minus 89.3 squared plus 95 minus 89.3 squared, 96 minus 89.3 squared. Now we will subtract the following, which is inside the parentheses. 1.7 squared plus 2.7 squared plus 3.7 squared plus negative 4.3 squared plus negative 2.3 squared plus negative 5.3 squared plus negative 7.3 squared plus negative 1.3 squared plus 5.7 squared plus 6.7 squared. Next is we will square the following. 2.89 plus 7.21 plus 13.69 plus 18.49 plus 5.29 plus 28.09 plus 53.29 plus 1.69 plus 32.49 plus 44.83. We will add the following. In group 2, the answer is 208.1. Now we will move on to the last group. 79.84.7 squared plus 78.84.7 squared plus 88.84.7 squared plus 94 minus 84.7 squared plus 92 minus 84.7 squared plus 85 minus 84.7 squared plus 83 minus 84.7 squared plus 85 minus 84.7 squared plus 82 minus 84.7 squared plus 81.84.7 squared. Next is we will subtract the following inside the parentheses. Negative 5.7 squared plus negative 6.7 squared plus 3.3 squared plus 9.3 squared plus 7.3 squared plus 0.3 squared plus negative 1.7 plus 0.3 squared plus negative 2.7 plus negative 3.7 squared. Now we will square the following. 32.49 plus 44.89 plus 10.89 plus 86.49 plus 53.29 plus 0.09 plus 2.89 plus 0.09 plus 7.29 plus 13.69. Now we will add the following. The answer in group 3 is 252.1. Now we will find the SSW equals 640.4 plus 208.1 plus 552.1 and equals to 1100.6, which is our SSW.
Now, in our step 4, we will going to calculate the SST or the total sum of squares using this formula. SST equals SSB or the sum of squares between plus SSW or the sum of squares within. SST equals 192.2 plus 1100.6 and it gives us 1292.8. And now, let's proceed in our step 5, fill in the ANOVA table. Now that we get the SSB, SSW, and the SST, we will going to fill it in the ANOVA table. So in our table, we have the sum of squares, degrees of freedom, mean squares, and the F. So we already calculate the sum of squares and now we will going to get the degrees of freedom. If you are wondering where the 2, 27, and 29 came from, but well, let's solve about it. So before that, kindly take note that N is our total observation, K is our number of groups. So N is our total observations. So we have 30 participants, 30 students whom participated in the study. So our K is 3 because we have 3 groups. So to calculate the degrees of freedom between, K minus 1 is equal, we have the 3 minus 1 is equal to 2. To calculate the degrees of freedom within, N minus K equals 30 minus 3 equals 27. And the total is N minus 1 equals 30 minus 1 is equal to 29. Therefore, the degrees of freedom in between and within is 27 and the total is 29. So to calculate the mean squares from our table, we will use this SSB divided by K minus 1. So our SSB or the sum of squares between is 192.2 and divided by 2, therefore it's 96.1. So in our mean square of within, we will use to calculate the SSW divided by N minus K. So our SSW or the sum of squares within is 1100.6 divided by 27 and it is equal of 40.8. So to calculate the F test, MSB divided by MSW. So 96.1 divided by 40.8 and the result will be 2.358. So the F statistics for this one-way ANOVA is 2.358. So to determine if this is a statistically significant result, we must compare this to the F critical value found in the F distribution table with the following values. A or the significance level equals 0.05, degree of freedom is equal to 2, degree of freedom within is equal to 27. And how are we going to find the critical value? In this table, we will going to find out the F critical value. And now, we have the critical value and it is 3.3541. Okay, since the F test in the ANOVA table is less than the critical value in the F distribution table, we failed to reject null hypothesis. Therefore, we don't have sufficient evidence to say that there is a statistically significant difference between the mean exam scores of the 3 groups.
So here is the example of two-way ANOVA. Suppose a botanist wants to know if plant growth is influenced by sunlight exposure and watering frequency. She plants 40 seeds and lets them grow for 1 month under different conditions for sunlight exposure and watering frequency. After 1 month, she records the height of each plant. The results are shown below. Step 1. Calculate sum of squares for factor A, water frequency. First, we will calculate the grand mean height of all 40 plants. Add all the given numbers and divide it by 40. And the answer will be 5.1525. Next, we will calculate the mean height of all plants watered daily. As you can see on the table, there are 2 types of it: water daily and weekly. So we'll first solve the group daily. We'll just add it and divide it by 20. So the answer will be 5.155. Next, we will calculate the mean height of all plants watered weekly. As I did on the daily, you'll just have to add it and divide it by 20. So the answer will be 5.15. Next, we will calculate the sum of squares factor A, watering frequency, by using the following formula, as shown below, where N is the sample size of group J, the symbol E is summation, the mean of group J, and the grand mean. So the formula equals 20, open parentheses, the sum of watered daily, which is 5.155, minus the sum mean of all plants, which is the 5.1525, close parentheses, to the power of 2, plus 20, open parentheses, the sum of watered weekly, which is 5.15, minus the sum of all plants, which is 5.1525, close parentheses, to the power of 2, equals 20, open parentheses, the difference of the water daily and the sum total of it, 0.0025, close parentheses, to the power of 2, plus 20, open parentheses, the difference of watered weekly minus the sum total of plants is equals to negative 0.0025, close parentheses, to the power of 2. And the answer of the 0.0025 to the power of 2, you'll have to multiply it twice. So the answer will be 0.0000625, close parentheses, plus 20, open parentheses, the answer of negative 0.0025 to the power of 2 is 0.0000625. So 20 times 0.0000625 is equals to 0.00125 plus 20 times 0.0000625 is equals to 0.000125 is equals to 0.0025. Step 2. Calculate sum of squares for factor B, sunlight exposure. First, we will calculate the grand mean height of all 40 plants. You'll just have to add it all and divide it by 40, so the answer will be 5.1525. Next, We will calculate the mean height of all plants with no sunlight exposure. First, we'll calculate the none. Add all the given numbers at the column none and divide it by 10. So 40.7 the total of all given numbers, which is 40.7, divided by 10 is equals to 4.07. Next, we will solve for the low sunlight. Add it all and the answer will be 51 divided by 10 is equals to 5.1. Next, we will solve the mean of medium sunlight. Add it all and the total will be 58.9 divided by 10, it will be 5.89. Next, and lastly, the mean of high sunlight. Add it all and the total will be 55.5 divided by 10 is equals to 5.55. Next, we will calculate the sum of squares for factor B, sunlight exposure, by using the following formula, the same as we used when we solved the factor A, which is the watering frequency. So it will be equals 10, open parenthesis, the total of non-exposure of sunlight, minus the total of all plants to the power of 2, plus 10, open parenthesis, the total of the answer of low sunlight minus the total of all plants to the power of 2, plus 10 times the total of medium sunlight minus the sum total of all plants to the power of 2, plus 10 times the total of high sunlight minus the total sum of all plants to the power of 2 equals 10 times negative 1.0825 to the power of 2 plus 10 times negative 0.0525 to the power of 2 plus 10 times 0.7375 to the power of 2 plus 10 times 0.3975 to the power, and the answer will be 18.76475.
Step 3. Calculate sum of squares within. Next, we will calculate the sum of squares within by taking the sum of square differences between each combination of factors and the individual plant heights. First, we will calculate the mean of factor A, or plants watered daily with no sunlight exposure. So, ang kailangan ng pangitan ng mean kay ang factor A, or plants watered daily with no sunlight exposure. So, ang mga values na belong sa factor A, i-add mo tanan then divide of 5. I-divide mo 5 kay 5 sa kabuo. So, ang mga values kay 4.8 plus 4.4 plus 3.2 plus 3.9 plus 4.4 divided by 5 equals 20.7 divided by 5 equals 4.14. So, kaya na naman tayo mean, which is 4.14, we can then calculate sum square differences for factor A, or plants watered daily with no sunlight exposure. So, i-minus mo ang mga values sa factor A with no sunlight exposure sa mean, which is 4.14, then square the results. Then after that, add all the results. Okay, so 4.8 minus 4.14 squared plus 4.4 minus 4.14 squared plus 3.2 minus 4.14 squared plus 3.9 minus 4.14 squared plus 4.4 minus 4.14 squared equals 0.66 squared plus 0.26 squared plus negative 0.94 squared plus negative 0.24 squared plus 0.26 squared equals 0.4356 plus 0.0676 plus 0.8836 plus 0.0576 plus 0.0676 equals 1.512. So 1.512 is your sum of squares for daily watering with no sunlight exposure. So next, calculate mean height of all factor A with low sunlight exposure. So, sunod na po nimo pangitanog mean kay ang factor A with low sunlight exposure. So, magyapon, add all the values of factor A, then divide by 5. So, 5 plus 5.2 plus 5.6 plus 4.3 plus 4.8 divided by 5 equals 24.9. Divided by 5 equals 4.98. So, the mean is 4.98. So, kaya naman yung mean, which is 4.98, we can then calculate the sum of square differences for factor A or plants that are daily with low sunlight exposure. So, magyapon, minus the value of factor A to the mean. Then square the results, then add all the results. So, 5 minus 4.98 squared plus 5.2 minus 4.98 squared plus 5.6 minus 4.98 squared plus 4.3 minus 4.98 squared plus 4.8 minus 4.98 squared equals 0.02 squared plus 0.22 squared plus 0.62 squared plus negative 0.68 squared plus negative 0.18 squared equals 0.004 plus 0.0484 plus 0.3844 plus 0.64624 plus 0.0324 equals 0.928. So, the sum of squares for factor A with low sunlight exposure is 0.928. Next, calculate the mean height of factor A with medium sunlight exposure. So, magyaba. So, 6.4 plus 6.2 plus 4.7 plus 5.5 plus 5.8 divided by 5 equals 28.6 divided by 5 equals 5.72. So, kaya naman yung mean, which is 5.72, we can then calculate the sum of square differences for factor A with medium sunlight exposure. So, 6.4 minus 5.72 squared plus 6.2 minus 5.72 squared plus 4.7 minus 5.72 squared plus 5.5 minus 5.72 squared plus 5.8 minus 5.72 squared equals 1.788. So, 1.788 is your sum of square differences for factor A with medium sunlight exposure. Next, calculate the mean height of factor A with high sunlight exposure. So, 6.3 plus 6.4 plus 5.6 plus 4.8 plus 5.8 divided by 5 equals 28.9 divided by 5 equals 5.78. So, 5.78 is the mean. So, naman yung mean, which is 5.78, we can then calculate the sum of square differences for factor A with high sunlight exposure. So, 6.3 minus 5.78 squared plus 6.4 minus 5.78 squared plus 5.6 minus 5.78 squared plus 4.8 minus 5.78 squared plus 5.8 minus 5.78 squared equals 1.648. So, 1.648 is the sum of square differences for factor A with high sunlight exposure. So, para mag-solve sa factor A, natin ba mag-solve sa factor B? So, again, sa pag-solve sa factor A, nataan niyo ba niyo pag-solve sa factor B? So, calculate the mean height of factor B with no sunlight exposure. So, magyapon, 4.4 plus 4.2 plus 3.8 plus 3.7 plus 3.9 equals, divided by 5 equals 20 divided by 5 equals 4. So, 4 is the mean. So, kinalaman yung mean, which is 4, we can then calculate the sum of square differences for factor B with no sunlight exposure. So, 4.4 minus 4 squared plus 4.2 minus 4 squared plus 3.8 minus 4 squared plus 3.7 minus 4 squared plus 3.9 minus 4 squared equals 0.4 squared plus 0.2 squared plus negative 0.2 squared plus negative 0.3 squared plus negative 0.1 squared equals 0.16 plus 0.04 plus 0.04 plus 0.09 plus 0.01 equals 0.34. So 0.34 is the sum of square differences for factor B with no sunlight exposure. Let's calculate the mean height of factor B with low sunlight exposure. So 4.9 plus 5.3 plus 5.7 plus 5.4 plus 4.8 divided by 5 equals 26.1 divided by 5 equals 5.22. So, kaya naman yung mean, which is 5.22. We can then calculate the sum of square differences for factor B, or plants watered weekly with low sunlight exposure. So 4.9 minus 5.22 squared plus 5.3 minus 5.22 squared plus 5.7 minus 5.22 squared plus 5.4 minus 5.22 squared plus 4.8 minus 5.22 squared equals 0.548. So 0.548 is the sum of square differences for factor B with low sunlight exposure. Let's calculate the mean height of factor B with medium sunlight exposure. So 5.8 plus 6.2 plus 6.3 plus 6.5 plus 5.5 divided by 5 equals 30.3 divided by 5 equals 6.06. So we can naman the mean, which is 6.06. We can then calculate the sum of square differences for factor B with medium sunlight exposure. So 5.8 minus 6.06 squared plus 6.2 minus 6.06 squared plus 6.3 minus 6.06 squared plus 6.5 minus 6.06 squared plus 5.5 minus 6.06 squared equals 0.652. So 0.652 is the sum of square differences for factor B with medium sunlight exposure. And lastly, calculate the mean height of factor B with high sunlight exposure. So 6 plus 4.9 plus 4.6 plus 5.6 plus 5.5 divided by 5 equals 26.6 divided by 5 equals 5.32. So kaya na naman yung mean, which is 5.32, we can then calculate the sum of square differences for factor B with high sunlight exposure. So 6 minus 5.32 squared plus 4.9 minus 5.32 squared plus 4.6 minus 5.32 squared plus 5.6 minus 5.32 squared plus 5.5 minus 5.32 squared equals 1.268. So 1.268 is the sum of square differences for factor B with high sunlight exposure. Kaya na naman tayo sum of squares for factor A and factor B. We can then take the sum of these values to find the sum of squares within. So, sum of squares within equals 1.512 plus 0.928 plus 1.788 plus 1.648 plus 0.34 plus 0.548 plus 0.652 plus 1.268 equals 8.684. So, 8.684 is the sum of squares within. 4. Calculate the total sum of squares. Next, we can calculate the total sum of squares by taking the sum of differences between each individual plant and the grand mean. Minus mo values sa factor of A and factor B to the grand mean, which is 5.1525, and square the results. Add the results and divide by 40. Divide by 40, 40 mo sinakabog. So, total sum of squares equals 4.8 minus 5.1525 squared plus 4.4 minus 5.1525 squared plus 3 plus 3.2 minus 5.1525 squared plus 3.9 minus 5.1525 squared plus 4.4 minus 5.1525 squared plus 4.4 minus 5.1525 squared plus 4.2 minus 5.1525 squared plus 3.8 minus 5.1525 squared plus 3.7 minus 5.1525 squared plus 3.9 minus 5.1525 squared plus 5.5 plus 5 minus 5.1525 squared plus 5.2 minus 5.1525 squared plus 5.6 minus 5.1525 squared plus 4.3 plus 4.3 minus 5.1525 squared plus 4.8 minus 5.1525 squared plus 4.9 minus 5.1525 squared plus 5.3 minus 5.1525 squared plus 4.2 minus 5.1525 squared plus 5.7 minus 5.1525 squared plus 1.4 minus 5.1525 squared plus 4.8 minus 5.1525 squared plus 6.4 minus 5.1525 squared plus 6.2 minus 5.1525 squared plus 4.7 minus 5.1525 squared plus 5.5 minus 5.1525 squared plus 5.8 minus 5.1525 squared plus 5.8 minus 5.1525 squared plus 6.25 minus 5.1525 squared plus 6.3 minus 5.1525 squared plus 6.5 minus 5.1525 squared plus 5.5 minus 5.1525 squared plus 6.3 minus 5.1525 squared plus 6.4 minus 5.1525 squared plus 5.6 minus 5.1525 squared plus 4.8 minus 5.1525 squared plus 5.1525 squared plus 6 minus 5.1525 squared plus 4.9 minus 5.1525 squared plus 4.6 minus 5.1525 squared plus 5.6 minus 5.1525 squared plus 5.5 minus 5.1525 squared divided by 40 equals 28.45975. So 28.45975 is the total sum of squares.
Step 5. Calculate sum of squares interaction. Next, we will calculate the sum of square interaction by using the formula below. SS interaction, or the sum of square interaction, equals sum of square total minus sum of square factor 1 minus sum of square factor 2 and minus sum of square within. So we need to substitute it all. So we have sum of square interaction equals 28.45975 minus 0.0025 minus 18.76475 minus 8.684. So the total is sum of square interaction equals 1.01075. Step 6. Fill in ANOVA table. Lastly, we'll fill in the values for the two-way ANOVA table. We have source of variation, the factor A, factor B, interaction within. So the next is total. So as you can see in the table, we have SS, DF, the MS, the F, and the P value. P-value watering frequency. The p-value that corresponds to p-value of 0.000921 with df numerator equals 1 and df denominator equals 32. P-value sunlight exposure. The p-value that corresponds to f value of 23.04898 with df numerator equals 3 and df denominator is equals to 32. The p-value interaction. The p-value that corresponds the f value of 1.241517 with df numerator equals 3 and df denominator equals 32. Note number 1. N equals total observation. J is equals to number of levels for watering frequency. K is equals to number of levels for sunlight exposure. Step 7. Interpret the results. We can observe the following from the ANOVA table. The p-value for the interaction between watering frequency and sunlight exposure was 0.311. This is not statistically significant at A equals 0.05. The p-value for watering frequency was 0.975. This is not statistically significant at A equals 0.05. The p-value for sunlight exposure was less than 0.000. This is statistically significant at A equals 0.05. These results indicate the sunlight exposure is the only factor that has a statistically significant effect on plant height. And because there is no interaction effect, the effect of sunlight exposure is consistent across each level of watering frequency. That is, whether a plant is watered daily or weekly has no impact on how sunlight exposure affects a plant.